Do you remember back before we did the quadratic formulas? Everybody listening? Before we did the quadratic formula, I made you learn how to simplify square roots, because in the quadratic formula you have the square root of b squared minus 4ac, and you ended up with a number underneath your square root. So let's go ahead and over to the side on your foldable, let's write down all the numbers that are perfect squares, okay? All the ones that we've memorized. So 2 times 2 is 4, 3 times 3 is 9, because we're going to use these numbers on this entire foldable. Those are our perfect square numbers, and you really need them memorized. If you don't, write them down the side of your foldable, really, really small. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. 7 times 7 is 49. 8 times 8 is 64. 9 times 9 is 81. 10 times 10 is 100. 11 times 11 is 121. And 12 times 12 is 144. Anybody know what 13 times 13 is? 169. Anybody know what 14 times 14 is? 196. And anybody know what 15 times 15 is?
225.
225. Okay. You definitely should have the perfect square numbers memorized through 144, but by now you might know what 13 times 13, 14 times 14, 15 times 15. Those are usually as far as we go. Okay, I bet y'all know what 20 times 20 is, though.
400.
400. So there are some other perfect squares that you could get pretty easily based on some things that you already know. Okay, so these numbers are always going to be used to simplify square roots. We're going to wear them out. We're going to use those perfect square numbers in this section and on this foldable underneath every single flap over and over and over and over again. Okay, so we're going to start with some things that you are already familiar with. So we have already simplified some square roots. For example, we have done something like the square root of 49 before. Okay? And anytime we have a number underneath the square root, we look at it and we ask ourselves, is it a perfect square? Is 49 a perfect square? It is. So the square root of 49 is just the number what? Just 7. Does 7 have a square root over it? Or is it just 7? Is it square root of 7 or is it just 7? Because some people can't remember whether to leave the square root.
Just 7.
Just 7. Okay? Because 7 times itself 2 times is 49, and that's what the square root symbol is asking you. What times itself 2 times is 49? So the answer is just 7. Alright, you've also seen some fractions underneath square roots. So if you saw the square root of 4 over 9, and even that, maybe even a negative sign out in front of that. So we're going to talk about two little things in this example. What do you do if there's a negative on the outside? And what do you do if there's a fraction on the inside? Well, the negative is just going to come down with your answer. So that could be a plus and a minus, or it could just be a minus, and that sign just comes down with your answer, and you're asked yourself, is 4 over 9 a perfect square? And if you have to ask yourself, is a fraction a perfect square, you're looking at the top and the bottom. So is 4 a perfect square? Yes. Is 9 a perfect square? Yes. If you answer yes and yes, that means the fraction is a perfect square. So what times itself 2 times is 4 over 9? 2 over 3. So you take the square root of a fraction just by taking the square root of the numerator, which is the top, and the denominator, which is the bottom. Do I need a square root here? Or is 2/3 times itself 2 times 4/9?
You don't need no.
I don't need no square root. Okay? I don't need a square root at all, because 4 over 9, 4 and 9 were both perfect squares. So our answer is just negative. Negative because that negative sign was hanging out to the left of the square root. You just bring it down with your answer. Okay, example 3 is just to remind you that we've seen a few problems that have plus and minus on the outside. You've actually already completed a worksheet where you had a few of these problems. So if you see plus and minus square root of 100, You know that that plus and that minus is just going to come down with your answer. Then you're going to ask yourself, is 100 a perfect square?
Yes.
Yes, it is. So your answer would be plus or minus 10, no square root. Plus or minus 10. Alright, there are a few problems that you're going to see that are going to have a square root. Like in example 4, the square root of 8 squared. Okay, and this is something that we've not talked about yet. Okay, so this one would be something new. Example 4 might be something that you've not seen before. So I need to teach you that the square root symbol and the 2 are called opposite operations. Okay, a square root and squaring something, those are opposite operations. And so opposite operations always cancel each other out. Just like what's the opposite operation to addition? Subtraction. So if you add 10 and you subtract 10, those cancel each other out. So squaring and square roots are opposite operations. So the square actually cancels out the square root, and your answer is just 8. Okay? There is a long way to this, but I really don't want you to do it. The square root of 8 times the square root of 8 is the square root of 64. And the square root of 64 is just 8. But I really would like for y'all to learn that squaring something and taking the square root are considered opposite operations, and they just literally cancel each other out, and you get whatever's underneath the square root.
So what's that?
The answer is 8. The square root of 8 squared is just 8. So the square root of 10 squared is just 10. The square root of 12 squared is just 12, because the square and the square root cancel each other out. All right, in example 5, we're going to start putting some variables in our problem. Okay, as far as I know, in no other math class have you ever had any variables underneath a square root symbol. Okay, not until Algebra B do you actually see this. All right. So we have the square root of 36, x to the 4th, y to the 6th. And we're going to start with a number because everybody, y'all know what to do with numbers, but I'm going to teach you today what to do with variables if they're under your square root. So we'll start with the 36. Is 36 a perfect square?
Yes, ma'am.
Yes, it is. So we're going to mark through the 36. We're going to take the square root of 36, which is 6. 6 is going to come out. Anytime you take the square root of something underneath the square root symbol, whatever the square root of that is comes out on the left-hand side. And now we're going to go to the variables. The variables are treated completely different. There is an understood, I'm going to put it in yellow, there's an understood little number that is not written, okay, but it is a little number 2, and it's called an index. That little number is called an index. And you may see problems later on that are asking you to find the cube root and the 4th root. Not today, okay? But if that little number is not written, it's understood to be a 2. So what that means is what times itself 2 times is 36. That's why we said 6. If we look at the variables, it's asking you what times itself 2 times is x to the 4th.
X squared?
X squared. X squared times x squared is x to the 4th. X squared times itself twice is x to the 4th. So we're going to cross through the x to the 4th, and we're going to bring out an x squared. And then we're going to look at our y. And it says, what times itself 2 times is y to the 6th. Y to the what times y to the what is y to the 6th.
3 times.
Y to the 3rd. Alright, now that's a totally different way of thinking. You haven't done the variables before. Okay? So let me make sure you understand. You don't have to write this down, but just think it. Do you understand that x squared times itself 2 times is x to the 4th? Y'all get that? Because what do we do with exponents if we're multiplying?
Add.
We add them. So x squared times itself 2 times is x to the 4th. and y cubed, or y to the third, times itself 2 times is y to the 6th. So when you're doing variables, you're not looking at 4, 9, 16, 25, 36, 49, 64, and 81, 100, and so forth. What you're really looking to see is your exponent divisible by, so you may know, 2. Okay, if you're taking the square root of a variable, you want your exponent to be divisible by 2, because when you multiply that variable times itself 2 times, you're having to add up those exponents. So that the sum of the exponents would have to be divisible by 2 for the variable to be a perfect square. Alright, so how do we know that we have the right answer here? Well, let's kind of think about it. So this is our answer, 6x squared y cubed. That is our answer. So what we're saying is 6x squared y cubed times itself, how many times? 2 times, is 36x to the 4th y to the 6th. So would that be true? Would 6x squared y cubed times 6x squared y cubed, would that be 36x to the 4th y to the 6th? Y'all get me? Because you got to start understanding this part or you're going to get really confused. So if you're just checking it in your mind, don't write this down. If you're just checking it in your mind, does everybody agree that 6x squared y to the 3rd times itself 2 times gives me 36x to the 4th y to the 6th? What's underneath that square root? Y'all get that? If not, you will, right? Alright, example 6. This is something that you've done before. This one's not going to have any variables. The reason I chose example 6 is because I want something to be under the square root that's not a perfect square. I want something to be under the square root that's not a perfect square. So you're going to say, is 48 a perfect square? The answer's going to be, no, it's not. So remember what we do if the number's not a perfect square? We find a perfect square number, the largest one that we possibly can find that will divide into 48. And this is where you might use your calculator. Is it 16? 4 goes into 48 12 times, but does something larger like 16 go into 48? If you're not sure, you take your calculator and do 48 divided by 16. Does 16 go into 48? Okay, 3 times. So if 16 goes into 48, you want to use the largest one or you're going to have to simplify a second time. So we're going to rewrite 48 as 16 times 3. You're going to find the largest perfect square number that will go into the number underneath your square root. Then you're going to mark out 16 because it's a perfect square. You're going to take the square root of 16, which is 4. 4 is going to come out to the left. Some of you got confused when we simplified radicals before and you didn't know what number to bring out. You always bring out the number that you took the square root of. And then the 3 has to stay underneath the square root. So 48 is not a perfect square. You're going to find the largest perfect square that will divide into 48. You're going to rewrite 48 as 16 times 3. Take the square root of 16, which is 4. 4 comes out to the left. 3 stays underneath. Alright, example 7. Shh. Y'all try to concentrate. If the problem starts out being as 6 square root of 25, got 9 examples and I'm almost finished. 6 square root of 25. This really means 6 times the square root of 25. Anytime two things are squished together without a symbol, that shows multiplication. So this really says 6 times 25. Is 25 a perfect square?
Yes, ma'am.
Yes, it is. So I can change the square root of 25 into just a 5. And remember, that's an understood multiplication between the 6 and the square root of 25. So since the square root of 25 is 5, then that problem really says 6 times 5, which gives me 30. When a number is written side by side with a square root, it's an understood multiplication problem. It's an understood multiplication problem. All right, example 8. 2 more examples. 3 times the square root of 20. 3 times the square root of 20, or 3 square root of 20. Alright, 20 is the number underneath your square root. Is it a perfect square?
No, ma'am.
No, it's not. What's the largest perfect square that will go into 20?
4.
4. So we're going to rewrite 20 as 4 times 5. And I like my 4 to come first for a reason. I like my perfect square number to come first because I'm fixing to slash through it and take the square root of 4. So the square root of 4 is
2.
2. Now, when the 2 comes out and there's already a number on the outside, those numbers get multiplied together. You can show this step, but the more you practice simplifying radicals, you'll probably just do this step in your head. You'll say the square root of 4 is 2. 2 times 3 is 6. So your outside number is going to be 6, and your inside number is going to be 5. Alright, if there's already a number on the outside, when you take the square root of 4, you get a 2. The 2 comes out. Those numbers get multiplied together. Alright, last example for simplifying. Example 9. Big square root, we're going to add the variables back in. 27 x to the 9th, y to the 10th. This one's going to be as hard as they get. Square root of 27, x to the 9th, y to the 10th. So let's start with 27. Is 27 a perfect square?
No, ma'am.
No, it's not. Okay. What's the largest perfect square number that will go into 27?
9.
9. Okay. So we're going to rewrite 27 as 9 times 3. All right, now you're going to have to tell your brain, hey brain, now I'm going to look at these variables. When you look at your variables, you're not thinking of your list 4, 9, 16, 25, 36, and 49. The variables don't work that way. If a variable is a perfect square, the exponent is divisible by 2. Okay? So look at your first variable, x. Its exponent is 9. Is 9 divisible by 2? Will 2 go into 9?
No, ma'am.
No, it won't. Okay, so you're going to have to break your x down. What you're going to do is you're going to take 1 away from the 9, and you're going to write x to the 8th. You're always going to take 1 away if your exponent is not divisible by 2, and you're going to rewrite x to the 9th as x to the 8th times x. You haven't changed the problem, you've just changed the way that it looks. So you're going to take 1 away from your 9, that gives me the 8, and you're going to rewrite x to the 9th as x to the 8th times x. Then you're going to look at the next variable. Its exponent is 10. Is 10 divisible by 2?
Yes, ma'am.
Yes, it is. So you don't have to break down or change the y. You'll just bring it down as y to the 10th. If your exponent is not divisible by 2, you always take 1 away, and you write down whatever that variable is with that exponent times your variable. Alright, now we're fixing to go through and mark out everything that's a perfect square and take the square root of that. So 9 is a perfect square. Mark it out. The square root of 9 is 3. 3 comes out. Alright, this 3 that's under the square root is not a perfect square. It has no factors that are perfect squares, so that 3 is going to stay under the square root. Go to the next thing that's underneath your square root. X to the 8th. So what times itself 2 times is x to the 8th. X to the 4th. So x to the 4th is going to come out. Then you're going to go to the next thing under your square root, and it's x to the 1. If you have an exponent that's less than 2, you just have to leave it underneath there, because nothing times itself 2 times is going to give you x to the 1. So that's going to stay. Go to the next one. What times itself 2 times is y to the 10th, y to the 5th. So y to the 5th is going to come out. And then whatever you didn't cross out stays underneath your square root. So what stays under the square root?
3.
The 3 and the
1.
the 3 and the x. Okay, so this is going to be the harder problems right here. So you're going to end up with 3x to the 4th, y to the 5th, out on the left-hand side, and then you'll end up with square root of 3x. All right, questions about number 9?